Okay, hello students. I said that I would go over this quiz review, so I will. Taking it from the top, here you're just being asked to sketch the angle and tell which quadrant or axis contains its terminal ray. So to sketch, for the degrees, I hope this is a piece of cake, but for anyone that didn't know, a negative angle wants to rotate in a clockwise direction, whereas a positive angle would rotate counterclockwise. For negative 256, you're going to rotate 180 degrees, then whatever's left over. So you can do 256 minus 180. We can see that from there would want to continue on 76 more degrees. So maybe to here. So now we can draw in our angle. It would have its initial ray here, its terminal ray there. So there's your sketch. Obviously, the terminal ray is contained by quadrant 2. And then I didn't ask for it because I asked for it later, but our reference angle would be this angle right here. And we got that anyway. We did 256 minus the 180 and got 76. So I'm just going to include that. The reference angle is 76, just to drive that point home again, give you a little more practice with it. That's our reference angle. Is there anything else we would do with this? Not really. We could talk about coterminal angles. We're going to talk about that soon anyway. But obviously a positive angle of whatever it is, 104? Yeah, 104 degrees would be coterminal. It would just rotate the other way, but it would land in the same position. There's other answers too. Let's do this one. I got a question about this one from someone in one of my classes. It's a little weird, but just because this angle is so big, you'd want to start breaking it down. You'd say, okay, 4008. Well, I can subtract away 360 a bunch of times, certainly at least 10 times. Let's do that. So 4008 minus 360 times 10 was 408. But we see we can subtract away 360 from that one more time to be left with 48. So to draw this angle, and you know, I conceded in class that this was a mistake on my part to ask you to draw this, but you have to draw 11 spirals because you know we're taking away 360 11 times, so we should go around 11 times and then just an extra 48. I'm going to try to draw it just for the sake of argument. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and an extra 48. Okay, nailed it. Totally worth it, by the way. Really good use of my time. Let's draw this one in green. So initial ray, terminal ray. And we live in quadrant 1. Neat. All right, what about this? Now we're in radians. So I'm starting to sound like a broken record, but the most important part with radians is probably just understanding that the x-axis is pi and 2 pi and 3 pi and blah, blah, blah. So if you can express that with a common denominator with the angle that you're given, you're going to be fine, in my opinion. Pi, this would be 10 pi over 10, which means 7 pi over 10 is just a little bit shy of that. Think about the halfway point, right? If this is 0 pi's over 10, then this is 5 pi's over 10. That's halfway between 0 and 10. So we can tell that 7 pi over 10 is beyond 90 degrees, but it's not quite 180 degrees. So it's definitely in quadrant 2. And how much further are we going? 2. So it's not quite to the halfway point. So there's your rotation angle. It would go that way. And we're supposed to just give the quadrant. It's quadrant 2 again. Now, what's the reference angle? Well, how much further would it be to get to the x-axis? It would be 3 pi over 10 more. So for those of you thinking about reference angles, the reference angle would be 3 pi over 10, if you're wondering. Okay, and then lastly, for this one, again, we can take away not 360 degrees like we did for number 2, but we can take away 24 pi over 12. 24 pi over 12 is 2 pi, so we're subtracting a full rotation. That would bring this down to 11 pi over 12. Okay, and again, I guess I had a real affinity for quadrant 2 angles when I came up with these angles off the top of my head. But we're in quadrant 2 again, because again, this would be 12 pi over 12. So if we rotate through 11 pi over 12, well, first we have to do the full rotation. We'd go bzzz, and then 11 pi over 12 means we are almost down to the x-axis, but not quite. So there's your sketch. We live in quadrant 2. And just for practice with reference angles, the reference angle would again be just the difference between the 11 pi over 12 and the 12 pi over 12. So it's 1 pi over 12. There you go. Determine which of the following angles are coterminal with 305. Okay, well, it ain't this one, scratch. Because if you took the 55 and added 360 to it, that would be what? 415? That's beyond the 305. They don't share a terminal ray. 485 is clearly wrong too. That's only what, 20 degrees off from this? There needs to be a difference of 360 for angles to be coterminal. Speaking of a difference of 360, if you add 360 to this, you get what? 665? Are any of these actually coterminal? Not 665. If you add 360 to that, we're going to be up to 1,000 something, so that's out. It looks like D is going to work. Because if I add these, I'll get 5, put down the 2, carry the 1, 10, 25. So yes, D is actually coterminal with it. Now for this, to get down to the negatives, if we subtract 360, I don't know, I'm not good at math. It's 305 minus 360. Negative 55, so H is in. And then negative 55 minus 360 more is negative 415, so that one's in. But that means this one's out. Wait, I put negative 415 twice? Ugh, what a dummy. Okay, this one's out. That's not a full 360 degree rotation. And I guess choose that one too, even though I put it twice. But that's it. All you're doing to determine whether angles are coterminal is adding on multiples of 360. If you can add it on once, twice, 3 times, 4 times, if you get these same angles, then they are coterminal. And if you don't, then they're not. I wonder how I would do the exact same thing, but in radians. Well, 360 is 2 pi. If you're working with pi over 5, then 2 pi is 10 pi over 5. So take your 24 pi over 5 and add this on or subtract it away. So for these positive ones, adding on 10 pi over 5 does give 34 pi over 5. So this is correct. Subtracting this gives 14 pi over 5. That's not an option. But subtracting 10 pi again, 10 pi over 5, I mean, you get 4 pi over 5. So that's correct. That means 9 pi over 5 is not correct. And what else? To get to 48, we'd be adding on 14 pi over 5. That's 38. Trying to get to 48. So we're just doubling it here. Doubling it isn't going to do it. We need to be adding 10 pi's over 5. Not going to happen. Wrong. All right, so from here, what if I subtract away another 10 pi over 5? Then I'm getting negative 6 pi over 5. So -4 pi over 5 doesn't work. Just changing the sign is not going to do it. We see that f does work. This here is a difference of 20 pi over 5. 20 pi over 5 is the same as 4 pi, which equals 2 pi just twice. So that's 2 full rotations away, so G works. And then 240, I don't know what that is. What's the difference between those two angles? Well, I guess technically 24 pi over 5 minus negative 240 pi over 5. You're basically adding. So you get 264 pi over 5. So that difference between them is not a clean multiple of 10 pi over 5. So that should be a no. No. So just those. Moving on. Find the reference angle. All right. Guess where 28 degrees is? It's in quadrant 1. Guess what the rule is in quadrant 1? Your reference angle is literally just equal to the given angle. So your reference angle is 28. Okay. Guess where 137 is? It's in quadrant 2. So the rule in quadrant 2 is your reference angle is 180 minus the given angle. So if you do 180 minus 137, you get 43. Angle C lives in quadrant 3, and there's a rule in quadrant 3 that says the reference angle equals the given angle minus 180, sort of the reverse of quadrant 2. So 245 take away 180 is 65. I didn't mean to put that equal sign. They're not equal. An angle and its reference angle are not equal. It's not right to say that. 65. Okay. And finally, we get an angle that's living down here in quadrant 4, shunk. And in quadrant 4, the rule is the reference angle is equal to 360 minus the given angle. So 360 minus 316 is 44. Yeah, 44. So there's the deal. So all those rules I just said that seemed so good, those only work when your angle is within the first rotation. So -800, well, that's, we can't just do that same rule. So what would you do? I know what I'd do. I would add on multiples of 360 until I got my first positive answer. Then I could apply my rule. So by the way, 2 of these is 720. That's not quite enough. But if you add on 3, that ought to make you positive. So -800 plus 3 360s. I'm getting 280, which pretty obviously lives in quadrant 4. It's 10 degrees past 270. By the way, 10 degrees past means it's 80 degrees more to get to the axis. So that's your answer, 80. 601. I guess we would add on 720. That gives me 119. That was a little embarrassing. I should have been able to do that in my head. So 119, where's that? Pretty sure it lives in quadrant 2. So I could just apply this rule right here. And I'd get 61 as my reference angle. Again, I did not mean to put an equal sign here. The angle and its reference angle are not equal. They're just sort of related. All right, 412. Well, add on 360. You get -52. And the good news about that is -52 in quadrant 4, the answer is just going to be 52 because -52 is just 52 units that away. So obviously the distance between the x-axis and the terminal ray is 52. So this guy's 52. It's kind of an easy one. And then the 1285, you just have to subtract away a bunch of 360s, maybe 5. Is that right? No, that's too many. Subtract away 3. And you'll be left with 205. Puts you squarely in quadrant 3, where you just subtract 180. So your reference angle is 25. That's it for reference angles in degrees. You should hopefully be okay with that. For radians, it's actually easier in my opinion. Again, the big takeaway is the x-axis, the axis that we're supposed to be, measuring how far away we are. Well, if I've got 11 as my denominator, this is an 11 pi over 11. How far away is 8 pi over 11? It's 3 pi over 11 radians away. So if you can sketch in that 8 pi over 11 is here, then the difference between that angle and the x-axis is just 3 pi over 11. And that by definition is what your reference angle is. It's that extra piece that gets you down to the x-axis. So 8 pi, oh geez, 3 pi over 11. And then guess what? 17 pi over 15. Well, if we rebrand this as 15 pi's over 15, then where's 17 pi over 15? Why, it's exactly 2 pi over 15 beyond that axis. So that's your reference angle, 2 pi over 15. Now 25 pi over 3. That's just 24 pi over 3 plus an extra pi over 3. But 24 pi over 3 is 8 pi, which is 4 full rotations. So essentially, this is all that matters. In part C, that angle wants to come around 1, 2, 3, 4, and then rotate through an extra pi over 3. And since a reference angle is the angle formed by the terminal ray and the x-axis, that extra pi over 3 at the end, that's your reference angle. That's it. 23 pi over 12, reference angle is pi over 12. So if you haven't figured out the rule yet, all you really have to do is find the difference between the given angle and the nearest multiple of the denominator. Because with the pi's over 12, what do we got? This is going to be 12 pi over 12. Then 2 pi over here would be 24 pi over 12. If we chose to rotate around again, this would be up to 36 pi over 12. This would kick up to 48 pi over 12. But we're always comparing against that x-axis. So, okay, well, 23 pi over 12, that's 1 pi over 12 away from 24. If I had given you, whatever, 53 pi over 12, well, that's 5 pi over 12 beyond the 48. So that would be your answer. That's really all you got to do. So with that said, the rest are cake, I hope. 6 pi over 6 is the closest. So I'm 1 pi over 6 radians away. And they're never negative. So you almost just ignore the sign. You're just wondering, how far off am I? Nearest multiple, 10 pi over 3 or 10 pi over 5. So I'm off by a difference of 3 pi over 5. That's it. That's your reference angle. Nearest multiple, 18, 2 pi over 9, done. Nearest multiple, well, 0, 2 pi over 7. Done. That's how you find reference angles when the angle's given in radians. All right, I think I did this in class, but guess what? I actually did a kind of crappy job. So I'm gonna do it again. First of all, figure out what quadrant you're in. Secant being negative, secant reciprocal cosine, cosine x values, where are negative x values? Quadrant 2 and quadrant 3. So I know my angle is in quadrant 2 or 3. Well, then I got a second little factoid over here. It says sine is positive. Sine is y values. y values are only negative here and here. So clearly, once you make this little sketch, quadrant 2 is the only quadrant in which secant is negative and sine is positive. So we know we're working with an angle that lives in quadrant 2. So sketch it in, not with a highlighter. Tired. Okay, I'm just going to draw this wherever. Now here's what I did wrong. I was telling you that secant is 1 over x. Yeah, that's not wrong. So I told you just to take the reciprocal of that and say that x was equal to negative 3 over root 10. That was a dumb idea. It wasn't wrong, but it was a dumb idea because secant, sure, it's 1 over x, but it's also r over x. And you might be better off in this problem just letting r not be 1. And then we can just say, okay, well, I guess, yeah, I'll just let the radius be root 10 and let the x value be negative 3. You got to attach the negative to the x. The radius can't be negative, but just do that. Then for x, y, r, you've got 2 of them already. Neither one of them is 1, but that's fine. You don't have to do that. So negative 3. This radius is root 10. Makes the math easier on y too. You get negative 3 all squared plus y squared equals root 10 squared. So you get 9 plus y squared equals normal 10. So you get y squared equals 1 because you're subtracting. Then you take the square root and you get y as plus or minus the square root of 1. But we know it's not plus or minus. We already figured out that we have to be in quadrant 2. And in quadrant 2, the y value has to be positive. So you can throw the negative value out, keep the positive. There will be other times when you're in quadrant 3 or quadrant 4, and you'd have to throw away the positive and keep the negative based on the quadrant that you landed in. So keep that straight. But now we know that y is 1. So now the rest is a piece of cake. Sin theta, cosine theta, tangent theta, secant theta, cosecant theta, cotangent theta. And it's kind of just plug and chug now. Sine is y over r. So sine is going to be 1 over root 10. And if we clean that up by multiplying by root 10 over root 10, we get root 10 over normal 10. By the way, sine is the reciprocal of cosecant. So if you take the reciprocal of this form, the 1 over root 10, you get root 10 over 1, aka root 10. So that one's done. Just be done with it. Cosine is the reciprocal of secant. So we know it's just the reciprocal of what we were given. It'll be negative 3 over root 10. But again, you would multiply that by root 10. So you get negative 3 root 10 over normal 10. And secant was the one they gave us. So that's a freebie, negative root 10 over 3. Tangent is y over x. So that's going to be 1 over negative 3, so negative 1/3. And cotangent is the reciprocal of that, so negative 3. But that's it. That's how you do it. Ugh. All right. I'm doing this during period 4 because I don't have a period 4. And I'm about to run out of time. I got 5 minutes. Let's see what I can get done in 5 minutes. So here's another example. This is the one that kind of jogged my memory on this. But again, where are we? Oh, it just says quadrant 3, right? That's kind of dumb and boring, but take it if I can get it. So for this, tangent is y over x. So if you want to try to draw this more to scale, notice that you only want to go left by 9 and down by 40. So this would be kind of a sharp angle. Then you could mark off a right triangle defined by these numbers. So that 40 is your y value. Really, it's negative 40. That 9 is your x value. Really, it's negative 9. You got to find your hypotenuse. We are clearly not on a unit circle. Unit circle would have a radius of 1. So we couldn't possibly have legs of 9 and 40. So we got to find the actual hypotenuse. And to do it, you'll just use Pythagorean Theorem. Yeah. So this circle is not a unit circle. No way. Let's do the Pythagorean Theorem. The 40 squared plus the 9 squared equals our radius squared. So 1600 plus 81 equals r squared. 1681 equals r squared. All right, guess what this is? It happens to be exactly 41. Yes, I did that on purpose. I wanted to give you numbers that were nice and clean. But so your radius is 41. These are your x's and y's. So now you just plug everything in. Sine is y over r. Cosine is x over r. Secant is the reciprocal of cosine, so r over x, r over y. Tangent is y over x. Cotangent is x over y. So just get those fractions plugged in there. Y over r, negative 40 over 41. Cosecant's the reciprocal. May as well do it next. X over r, negative 9 over 41. Flip it. And tangent is the one that was given to us, so 40 over 9. And then do the reciprocal of that. That's it. Okay. Ugh. Yeah, I'll come back to this. Got to stop for the moment.